Assalamualaikum warahmatullahi ta'ala wabarakatuh and good morning. Today I would like to present our research about effect of Carter geometrical features for machining polyether ether ketone PEEK using Taguchi method. I am as a presenter Muhammad Rafiq bin Rosman and my supervisor is Associate Professor Dr. Raza Ijamsa bin Raja Abdullah. What is PEEK? PEK is a thermoplastic polymer consisted of aromatic ring structure bridging with ketone group and two other linkage. Second, what characteristic of PEK is first, excellent stability and high temperature. Second, resistant to chemicals and radiations. Third, good strength. And the last is biocompatible. The applications of PEK. Due to its good chemical and mechanical structure, PEK was commercialized in implant components for orthopedic and trauma applications. An alternative for the medical implant to replace metal-based implants such as titanium and stainless steels because of its biodegradable characteristics and non-allergic reactions compared to metal implants. Examples of PEK that have been used in orthopedic and medical field is such as spinal fusion cages, artificial discs, and femoral stems. The problem statements for the research is in current industry practice, to machining the PEK, manufacturer always use the same knowledge to machining metals, even it is different kind of materials. Furthermore, previous research also are more focusing on machining performances such as cutting speed, fill rate, and depth of cut, while challenges in machining PEK such as rough machine surface, tool wear, soft materials compared to metal. Our objectives of the research is the main goal of this research is to establish the effects of Carter geometrical features, which are helix angle, rake angle, clearance angle, and fluid number towards surface roughness. For methodology part, we use Taguchi method as a design of our experiment. There have been 9 experimental runs, consist of difference value of helix angle, rake angle, clearance angle, and flux number. While we constant the milling parameters for the spindle speed, we use 4,770 revolution per minute. For the feed rate, we use 0.05 millimeter per tooth. For the depth of cut, we use 5 millimeter, and we cut it in dry condition. The equipment that have been used for this research is first, CNC tool cutter grinder Michael Decker to make a cutting tool. Our cutting tool is end mill, and then we use for machining CNC milling Haas, and then for the surface roughness, we use surface roughness tester. So we go deep into the results and discussion. The graph shows the main effect plot for SN ratio. From this graph, it shows the best desired result shows the highest SN ratio. From the graph, it reveals a smaller number of fluids contribute to the highest SN ratio, which indicates a strong relationship on surface roughness formation. The hard thermoplastic polymer like PEK require fewer numbers of fluid to provide the greater space for chip ejection and reduce friction at the cutting zone. For the helix angle, too high helix angles increases the friction of the machine surface, while too low of helix angle can reduce the shearing action. Thus, the optimum value of the helix angle at 30 degrees is enough to minimize the rubbing between tool and workpiece and provide better shearing action. It also shows that the increasing rake angle value will increase the shear stress, which indirectly worsens the surface. Lastly, the clearance angle gives less significant effects on surface roughness. We move on to the table SN ratio response. This shows the factor that contribute to the largest effect on the surface roughness value. The number of loads contributed as the main effect towards surface roughness as changing of the level will give a dramatic change of surface roughness. It followed by helix angle, rake angle, and clearance angle. I hope you all is clear about my results and discussion. So, the conclusion, it is evident that cutter geometrical features, namely rectangle, clearance angle, helix angle, and the number of fluids have significant effects on machining surface roughness. The number of fluids is the most significant factor that affects the surface roughness value. The findings from the conducted investigation can be used as an input for the development of new cutter design specifically for machining PEEK material. That's all for today. Thank you for listening. Thank you very much.